Hello students, welcome back to another video tutorial lesson from the Apex Institute of Applied Mathematics Education. My name is Akin, your math instructor, and we are back with part 2 of the introduction to algebra. Of course, by now you would have already seen that upload, which was a few hours ago, and we would have gone through the fundamental aspect. That is, let me just pull up a recap here for you. You'd have seen where we went through the different variables that is used to represent an algebraic expression. We looked at coefficients, we looked at powers, we looked at terms, we looked at x variables. We also went through the whole aspect of looking at why terms are like versus why they're unlike. We looked at a couple examples that gives us the rules as to what we can and cannot do when it comes to algebraic expressions, and we did went through some examples which, as you can see here, are already done. If it is that you want to actually see the process of elimination or the process of simplification, then do check that video out. A link will be in the description and pin in the comments down below. But it's now time to move on to another phase of algebra, and this is in fact the multiplication and or division aspect of algebraic simplification, algebraic expression simplification. Of course, if this is the first time here on the channel, I do primarily offer contents that is related to the CSEC, CCSLC, SEA, EDXL, City and Guilds, and SAT questions. Of course, I haven't had a lot of time to do a lot of videos on those areas of math, those curriculums, but those will definitely be coming out very soon. But primarily now, to build the platform, which you guys can help me with by subscribing to the channel, hitting that like button, and share this out to your math groups, school groups, anyone who you know may be struggling with math, whether for a long time or of recent. You have just found the channel that will perhaps change your perspective on every aspect in math. So go ahead and hit that like button. It really does help the channel to grow. And of course, feel free to leave your comments down below if you find value from the video. I'd love to hear from some of you guys, and as well as respond to you. So do not forget to share the link out. Let's jump right into the session. As you can see here by the title, we are in fact learning how to multiply and divide algebraic expressions, and you'll see here that we have two rules. Now, these two rules are somewhat of a premature exposure to a topic that will be coming up soon and very soon, known as the laws of indices. And in that particular video, I will be discussing 5 more laws, but for now you're going to be prematurely exposed to law 1 and law 2. For now, we're just going to be calling them rule 1 and rule 2. And so with rule 1, what we're looking at here is if the bases are the same, once we are multiplying, then we are going to be adding the powers. If the bases are the same, we are going to be adding the powers when we are multiplying. Okay, however, with rule 2, it says that if the bases are the same, that is it, if the bases are the same, but instead we are dividing, then what we're going to be doing is that we're going to be subtracting the powers. Now, in the previous tutorial, when we were discussing what exactly are exponents and powers, we did say that we are not going to be limiting our skill set to just the powers being positive whole, but it can be negative whole, it can be positive fraction, it can be negative fraction, it can be a decimal to that extent. But at this level, we're going to hold our limit to positive and negative whole, positive and negative fractions, just to give you an idea. So we're going to be spending about 45 minutes here together, going through a bunch of examples, wide variety of examples that can come to you on a exam type question there. Okay, so of course, hit that like button if you have not done so already. So we're going to be starting off with the very basics. This is how I build my platform, by allowing students to drool in the fundamentals of math, because that's where the key, that's where the loop, that's where the hole is in most students' challenge with math, the fundamentals. So here we go. Now let's say that you were given an expression that says here then x to the power of 4, and I'm going to be using this period sign here as a multiplication sign interchangeably with the actual multiplication sign, because usually my variable x and the time sign tends to look alike. So I really do not like to give my students anything to confuse them. I like to make things clear. So this period sign here is the sign that I'm going to be using for my multiplication, so make note of that. So here we have x to the power of 4 multiplied by x to the power of 5. Okay, how do we simplify? Remember that we're not solving anything here because we have an unknown variable here. Now x to the power of 4 multiplied by x to the power of 5 brings out rule number 1, and that is, in fact, we're going to be rewriting the base. That's going to be x raised to the power of 4 plus 5. Now, of course, if you're an advanced student, you could simply just add 4 plus 5 in your mind, and then you would simply get the answer of x to the power of 9. I do strongly recommend that from the fundamentals of algebra, you want to practice to write these down, because for now it is going to be quite easy, but later on when you have to deal with positive integers, then you might cause yourself to have to make fundamental mistakes, such as forgetting how to add or subtract integers. Of course, if you have issues with that and you're constantly having to go on the calculator to simplify basic problems like this, then I recommend that you watch the video. That's a link will be pinned in the description box below, or right here in the cards you'll find a link that will take you to a complete tutorial on adding and subtracting integers. Then here, let's go. So then the answer becomes x to the power of 9. Let's then look at an example then where we have, say for example here, a to the power of 5 multiplied by a to the power of negative 2. So here then we are going to be looking at what if one of the powers was negative and one was positive. It could be either, it could be this one or it could be that one. It's going to be more or less the same. So what we're looking at then here is rewriting the base and adding the power of the 5 to the negative 2, like that. And we really like to actually put the negative in a bracket to associate the negative away from the positive, so you'll see clearly that there's a clash of sign here. So then what we're looking at then is saying that a is equal to, instead of 5 plus negative 2, we can simply write 5 take away 2 because of that sign clash. You'll recognize here then that, say here, negative times positive gives us a negative sign then here. Okay, so then we end up with a final answer here of a raised to the positive 3. And like I said, it could be either of the numbers being positive or negative, but you're gonna apply the same principle then here. Now let's look at this third example then. See, we have y to the minus 5 multiplied by y to the negative 8. So then what are we looking at then here is negative 5 plus negative 8. So that's rewriting the base, minus 5 plus negative 8. I strongly recommend, as I've taught my students in my live classes, do not try to add in your mind unless you're really advanced. Then I don't think that you'd be watching this video. If you're actually watching this video, it would mean that this is probably a weak area in your math, and so you're now going to be recognizing why it is that you often get these little questions incorrect. Then so if we zoom up here a little bit, you'll realize here that there's a sign clash here, and this sign clash here is that the positive meets the negative and we end up with a negative right here instead of 2 signs. So now what we then end up with here is y raised to the minus 5 minus 8. And that brings us to the rule of the like signs rule. Once the signs are alike, then what we do is add both numbers and keep the common sign. So we then end up with y raised to the minus 13. That is 8 plus 5 is 13. And the two negatives are alike, so we keep the negative sign. A lot of students I've heard over the years, for the past 10 years, they have constantly confused when we are multiplying negatives versus when we're adding negatives. If you're adding something negative to something that is already negative, it's going to become even more negative. But if you're multiplying two negative signs, then the result turns out that it's going to be positive. So do not get it mixed up then here. Okay, so of course the examples I'm going to be showing you now are more like where we would use these in indices. So you're getting a quick little dose, a little hint of what's coming on the channel. So definitely want to hit that subscribe button below to see when it comes. But for algebra, we are limiting our basis to, say here, letters, variables. But in the event that you see something like, say for example, 3 to the minus 2 multiplied, say here, by 3 to the 4, then it's the same concept. You're going to find that you might be tempted to say 3 multiplied by 3 is 9, but we do not multiply the bases. We only multiply the bases if it is that we actually would have different powers, and then we wouldn't even multiply the bases. We'd have to have like a variable beside it here, which we're going to be looking at in a few minutes from now. I'll show you when you multiply these numbers, but for now we're going to visualize the 3 and the 3 here as being the x and the x. We're simply going to rewrite the base here, and we're going to be adding the power. So that's minus 2 plus 4. This works out to be 3 squared. Negative 2 plus 4, we take the smaller number from the larger number, and we're going to keep the sign of the larger number. The sign of the larger number is positive, so 2 from 4 is positive 2. Now in this type of question here, we can actually evaluate, we can actually solve this, because we then can find out that 3 squared is in fact 3 multiplied by 3, which is equal to 9. But we're not doing the solving process. I just needed to just let you know that that's coming up soon on the channel. We are going to be using this rule here to actually evaluate exponential quantities and solve exponential equations. So for now, for this particular tutorial, we're going to keep our limits to algebraic basis here. All right. So if that kind of clears up the whole understanding behind adding powers when we're multiplying, then of course hit that like button. Okay, now what then if we had coefficients involved with this? Then what else if we had, say here, 3, I think I like the number 3 too much, let's do something else. Let's say 5, say here, x squared multiplied by, say here, 3x to the 4th. Now let's be careful here, because in our previous tutorial we had mentioned that unlike terms cannot be added or subtracted, but we didn't really say that they can't be multiplied, because now we're learning that they can. Yes, x squared is not the same as x fourth, but if we were asked to add this, then we would literally have the answer already. 5x squared plus 3x4 is in fact 5x squared plus 3x4, but we are multiplying. So what we can do here is that we can actually take out the actual numbers here, and there's a reason why I'm doing it like this, because in a few minutes it's going to become a little advanced. I want you to practice to take out the numbers, that is 5 times 3 in a bracket like so, and then we want to organize, say here, x squared and multiply that with x4. So we group numbers with numbers, or coefficients with coefficients, and bases or variables with variables. Okay, so then 5 times 3 here is going to be 15, and of course x here, same base, so we're going to be adding the power, so we end up with 2 plus 4. That works out here to be 15 raised to the 15x raised to the power of 6. So you have to look out for when that happens here, okay, when you have coefficients. And it doesn't matter if the coefficients are negative or positive, the coefficients can always be multiplied. then here, but the powers are going to be added, and it doesn't matter if the powers are the same, right? We're going to be adding them. It's now the base. The base is now what determines whether we add or subtract. Okay, if the bases are the same, well, they have to both be the same, but if it is that we are multiplying, then we are going to be adding powers. Now we're going to be moving on to some examples where we are actually dividing the powers here. All right, so let's move on to some of the examples with division. Rule number 2 then in fact states that if we are dividing and the bases are the same, then we in fact subtract the power. So what then if we had, say for example here, a to the positive 10 divided by, say here, a to the positive 3, then what will happen here is that we end up with a raised to the 10 take away 3, because we're dividing. So then this works out to be a raised to the 7. Easy problem there. Let's say then, let's move on to another example here. Let's say that we had x, oops, don't like how that x looks, guys. X raised to then the positive, let's say negative 5 here, and we're going to be dividing that then by x, pardon me, x raised to the negative 4. What happens then if both powers are negative? We have to be very careful with this, because like I said, there are levels to this. If it is that you're an advanced, intermediate to advanced student like myself, you'd probably be able to see that the answer here is going to be -1. But what about the student who makes that little sign mistake? How can you avoid that? You can avoid that by sticking to your fundamentals, by writing down, so x to the negative 5, because you're dividing, you're going to be subtracting. Let's pause. This subtraction sign here, let me put it in a different color for you here. This subtraction sign here in red is as a result of the fact that we are dividing, but it's independent from the subtraction sign that is on this 4 here. So this negative red sign here, this red negative sign here, is because we are dividing. So you're going to be subtracting the power over here, which is -4. Too many times I find that students, because they're told to subtract the powers, they tend to use this minus sign as the subtraction sign, which is going to be yet again a brutal mistake, a brutal fundamental mistake, which can cause more damage than good. So then here we have x raised to the -5, negative multiplied. Remember that a bracket has an implied multiplication sign. So a negative then multiplied by a negative will then give us now positive. Okay, we are not adding two negatives, we are multiplying two negatives. So then we get a +4. And then easily then, using the unlike signs rule, if the signs are different, then we take the smaller, which is 4, from the larger, which is 5. We're going to be left with 1, but the sign of the larger number, which is 5, is negative, so it becomes -1. And of course, we can't really solve this because we don't know what x is. We can rewrite it in another way. If you students know about advanced algebra, then you'll know about the rule of indices, law number 3, about the negative index power. If you haven't, then look out for that tutorial video. You'll soon learn how it is that I move from x to the -1 to being 1/x. So look out for that. So then what happens then if one of the power is negative and one is positive? Let's say then that we have, say here, t raised to the -2 divided by t raised to the 7. Tricky. You have to be careful. I have seen this way too many times with students that are attempting to do CSEC, and so many times over when they're doing CSEC math, they tend to always make this mistake here by subtracting the power. So mentally in their mind, what they're seeing is 2 take away 7, when in fact it is -2 take away 7. Remember, it only takes you writing down a wrong sign or miscalculating the signs to get this question incorrect. So it's such a delicate question, but if applied correctly, you'll find that you can easily get the answer by being patient and being fundamental. T raised to the -2, this division sign brings out, of course, this negative sign here, but we are then subtracting, say here, 7. So it's positive 7, which lands in front of the negative. Then that gives us a like sign rule. When the signs are alike, we add both numbers, so that's negative 9. Add both numbers and keep the negative sign, so that's negative 9. Again, this cannot be resolved, but we can rewrite this and you'll find out that this becomes 1 over t to the 9. You will soon learn how we do that conversion by using indices law number 3, negative index law. Once again, I have to drop in here the fact that it could be numerical, where in this case maybe you should be able to find the value. So let's say that we have 4 to the 8 here divided by, say here, 4 to the negative 4. So what then are we looking at? Let's try something easier. Let's try 4 to the 2 divided by 4 to the minus 4. The bases are the same, so do not say 4 divided by 4 is 1. We say rewrite the base and subtract the powers. Once again, this subtraction sign is independent from the negative that is on the 4. So then it's, say here, like this. So this is going to be 4 squared, negative times negative, bracket implies a multiplication, negative times negative is positive, so that's plus 4. So we end up with 4 to the power of 6. So 4 to the power of 6, if you were asked to write down the actual answer, then 4 to the power of 6 would actually work out here to be 4096, but we're not actually evaluating or solving the expression. I was just dropping in here an extra bonus that it's the same concept in algebra as it is same in the arithmetic format of this particular question here. And it's the same thing if we had, say for example, 12x to the, let's use 12y then. Let's say 12y to the minus 2 divided by, say here, 3y to the minus 7. Then if you had something like this to simplify, then you'll find that here 12 divided by 3, I'm going to keep it simple in bracket here, then we're going to have the bases organized by itself outside, so that's y minus 2 divided by, say here, y minus 7. So obviously then 12 divided by 3 is in fact 4, and we're going to rewrite the base as being y, but then the power here is minus 2, and this negative sign here that is in red is independent from the negative sign that is on the 7. So that's minus 7 here. So that's minus 7 here. Okay, and so then to simplify our answer, we then end up with 4y minus 2, negative multiplied by negative is a positive 7. Simplify to 4y. Unlike signs, take the smaller from the larger, and of course we're gonna have positive 5. Since the positive is in front of the 7, then the power here remains as positive. So our final result here is 4y to the positive 5. Okay, so 8 examples really gives us a rounded feeling of what this type of question is. What can we expect? Of course, in part 1 we went through the addition and subtraction aspect. You would see the difference then, that our main focus now is no longer on the base, but it's now on the powers. The bases are in fact just a case where it helps us to determine whether we should add, it helps us to determine if we can apply rule 1 and rule 2. Now you might be asking then, what then if the bases are different? Well, there is actually no rule for that when it comes to multiplication or division. Let's say then that we had, say, x to the 4th multiplied by y cubed. Then in this case here, we have no choice but to merge them together. Remember, if it was addition, that would just be it. But if it's multiplication, then we could just rewrite it in a simpler format by saying x to the power of 4 y to the power of 3. We can't do much there. We cannot add the powers because the bases are not the same. So we kind of merge them together, which is why whenever you see an expression like this in the future, it means an implied multiplication. We move it from the actual sign to just merging it together to a more understood expression. But for the most part, we're just going to be focusing on when the actual bases are the same. If it is that you're getting some value from the video, please go ahead and hit that like button, guys. It really does help the channel to grow. It will be my absolute pleasure to be helping students all over the Caribbean. So if you have a friend, if you have a family member, a cousin, a sister, a brother who is struggling with math, who is getting ready for CSEC exams, who are in 4th form, who are in 3rd form, wherever you are and you're watching this video, if each of you can share this to someone, it really does help the channel to grow, and it also helps you to help someone else, which automatically helps me to help everyone to learn and become better math students. This is where it begins. Your advanced level in algebra is about to be unlocked. Let's move on to phase 2 of this video. Now, it's very important that we understand that using all these tools that we have acquired so far will come down to this aspect of math. Well, in fact, before I actually move on to phase 2, I didn't realize, even though I really don't want to go in depth with it, but what happens then, I really didn't remember this, but what happens then if the power is a fraction? Okay, let's say then that we have p to the 2/3 multiplied then by p to the 1/5. Okay, now this will bring out our fraction knowledge, and I don't have an exact tutorial on the fundamental principles of fractions and how to add or subtract fractions, but I do have a video out on fraction application questions. So you would have seen where I had explained that once you end up with a proper or improper fraction and you're adding or subtracting, then you're gonna find that you have to in fact add the powers, or what I would say, find the LCM. So then we'd of course rewrite the base then, and we'll end up with p raised to the 2/3 plus 1/5. Now for some students, for me, I can look at this and say that the answer is going to be 7/15. But how was I able to look at this and see that the answer is 7/15? There is in fact a shortcut to it, and I'm going to show you in example number 2. But let's just take the fundamental approach to this. We'll just take the 2/3 here and the 1/5 here, and we go ahead and find the LCM. This is for the fundamental student. So then the LCM here is 15. 3 times 5 is 15. 3 into 15 goes 5 times. We multiply it by the top. Then 5 into 15 goes 3 times. Multiply it by the top. I did make a mistake here. It's not actually 7/15. I thought it was subtraction, not paying attention, but it is in fact 13/15. Well, let's see how we got it. 5 times 2 is 10. 3 times 1 is 3. So we end up with the power being 13/15. So our result here for this question is p raised to the 13/15. That is our result. All right. So how was I able to actually look at it and be able to see it? Let me show you a shortcut in simplifying fractions like this one without even thinking too much about the whole LCM aspect. So here what we do now is, say we have r raised to the 2/3, or let's do something else, r raised to the 1/4 multiplied by r raised to the 3/8. All right, or let's do 3/5 here. So then what we have then is r raised to the 1/4 plus 3/5. So in my mind, let me zoom up here for you. In my mind, what I'm doing now is that I'm multiplying the 5 with the 1. That gives me, let me just rewrite my base here first. r. So what I'm doing in my mind is that I'm actually saying to myself 5 times 1 is 5. Then I'm saying here 4 times 3 is 12. Okay, so I'm saying 4 times 3 is in fact 12. And then in my mind I'm multiplying the bottom here, the wings or the bases of the wings. That's what I'm doing. So then I have 4 5s is in fact, say here, 20. So then I end up with here, say 20. So in my mind I'm quickly doing this and I'm not taking too long. I recommend that it's something that you practice. It really does make the working out more efficient. But if you feel like it's a little confusing and you're not very versed at doing it in your mind, then by all means use method 1. But for me here, this is quickly going to be r raised to the 17 over 20. All right. And the same principle applies if it was division. Let me not leave that as a loophole in this video. I do not want you guys to actually take up a problem and be watching my videos and you're not seeing examples of this. So let's say that we have, let's go back to our usual x. Let's say we have x raised to the 4 over 3 divided by, say here, x to the 2/3 or 2/5. Okay, so in my mind it's the same thing. I'm rewriting the x and I'm saying 4 over 3 take away 2 over 5. Remember, this is in fact division, so we're subtracting the powers. So in my mind, when I look at this, I'm thinking that the answer is basically going to be 15 over 15, which is going to be, say, x to the 1. Okay, because 5 times 4 is 20, so that becomes x raised to the 20. Take away 2 times 3 is 6. So sorry, it's not 15 over 15. Making a lot of mistakes today, guys, but that's okay. I've catch myself. And then we have 3 times 5 is 15, so that's here. So then we have x raised to the 14 over 15. All right, and that basically gives us a simplified version for our answer. So you have to use this principle. It works when it's division, it works when it's subtraction. Sorry, it works when it's division, it works when it's multiplication. But you also have to understand that we can set up questions in the future that where the power is negative. So you have to still take the approach of sign clashes. And I'm going to try to actually make a... I'm thinking that maybe I should make a part 2, or should I continue with you guys for another, say here, 13 minutes? Let's just continue rather than doing a part 2. Let's just continue. If you have reached this part of the video, it is okay for you to take a little break, pause the video and have a drink of water, some juice, some snacks, get back to the video and let's continue. Let's push on. Okay, so then what we are looking at here is in fact advanced questions. Then how do we simplify advanced questions using all that we have learned so far? What would an exam question look like if you were to get one? Or what would a math teacher in class try to challenge you with using this information then? Let's say then you're asked to simplify. You're asked to simplify here. Let's keep it simple. 4x squared y fourth multiplied then by 3x to the 5y cube multiplied then by 2x to the 7y squared. Okay, all multiplication. So then what are we looking at then is we can actually do this in our mind. Again, for intermediate to advanced students, you guys should be able to actually say 4 times 3 is 12, 12 times 2 is 24. I do appreciate students who actually try to show their working. I really do appreciate that, but like I said, depending on what level of math you're doing, whether it's college level math, you may have to skip out a few steps because that's kind of a little tedious at this level. If you're really learning this for the first time, you're getting an understanding, I do recommend that you take the approach that I'm doing here until when you become an advanced student, then you can skip out a few. But for now, let's keep it like this. We're going to be taking out the coefficients then. So we're going to be taking out, say here, all the coefficients 4 multiply then by 3, multiply then by 2. Then we're going to be taking out all the x's, so we have x squared here. We're going to be multiplying that by this x over here, x to the 5. We're going to be multiplying it by this x over here, which is x to the 7. Remember that when the answer is completed, it's going to be all joined together, so everything is still again joined by a multiplication. Then we're going to have here, say, y to the 4th multiplied by y to the 3 multiplied by y squared. Okay, so when we do it this way, it's easy for us to get the answer, because then we won't have to second guess ourselves. 4 times 3 is in fact going to be, say here, 12. 12 times 2 is 24, so that's 24. Okay, and then now we know that if the bases are the same, we're going to be adding the power, so that's 2 plus 5 plus 7, and then we're going to have y 4 plus 3 plus 2. Okay, so then our final answer here works out to be 24x. 2 plus 5 is 7, 7 plus 7 is 14, and 4 plus 3 is 7, 7 plus 2 is 9, so that's y to the 9. So this here becomes our final result, 24x to the power of 14, y to the power of 9. All right, and that's how you take on a question like that. But that's easy. What then if it is that we had some change up in the sign, some negatives and mix with some positives? Let's look at a straight multiplication with that. We're really going through the whole entire theorem in less than 45 minutes with a fine teeth comb. Let's go through everything here. We're looking at, say here, 5x to the minus, okay, let's not use negatives as yet. Oh yeah, let's put some negatives. So 5x to the minus 3, say here y to the 4th, say here multiplied by 2x, say here 2x and y raised to the minus 5. Then we have, say here, multiply again, say here by 3x to the minus 1, y to the minus 7. Okay, and we have this to simplify. How do we approach this then? The same exact way. We're going to be going through the whole principles of taking out our coefficients. That's 5 multiplied by 2 multiplied by 3 in bracket here. Then we're going to be taking out all our x's and putting them beside each other. Okay, so we have x raised to the minus 3. We're going to be multiplying that by, say here, y. Oops, my mistake. X. Now you don't see a power here, and so be careful not to think that the minus 5 goes for both terms. Okay, the minus 5 is on the y, it's the power of the y, but the x doesn't have an indicated power. And when you have a variable that doesn't have an indicated power, then guess what? The power is in fact, you got it right, 1. The power is 1. Multiply then by this x over here, which is x raised to the minus 1. Once again, our final answer will be joined together, so it's the x and the y is joined by a multiplication. So we have y here to the power of 4. Let me use a different color ink to make sure that we have a clear understanding. All right, so here we have y raised to the power of 4 multiplied then by this y raised to the power of minus 5 multiplied then by this y raised to the power of minus 7. Then finally, then what do we have then? 5 times 2 is 10, 10 times 3 is going to be 30. Then we end up with the base being the same here, so the power here is minus 3. Obviously we are multiplying, so we are adding the powers 1, and we're going to be adding the power here again, minus 1. And then we have now y here, the power here is 4. We're going to be adding the power of minus 5, and then we're going to be adding the power of minus 7 here. Now, I always tend to be very sarcastic with my students because I kind of try to influence them that calculators are not a necessity. I do this all the time. I'll let my students know that, hey, I cannot afford to buy a calculator, so my brain has to be working. I have to imagine myself not having a calculator, and once I can imagine myself not being able to use a calculator, there has to be means and ways for me to go around the problem. Okay, so here I'll end up with minus 3. Okay, we need a little bit more simplification here. Minus 3 plus 1, and then of course zooming up here, you'll realize that this is 1. Negative times positive is a negative, so this becomes a minus 1 instead of a plus negative 1. Okay, then I have y here, then I have 4. Again, zooming up, you'll realize that there's a positive mixed with a negative here, so that becomes a negative 5, and again a positive mixed with a negative becomes a negative here, so that's negative 7. Again, all of these steps are for students who are at the fundamental level of algebra. If you're an intermediate to advanced students, obviously I would not have gone through this whole process of getting my answer. I would have already just moved from here all the way down to here. I would have skipped out those 2 steps. But the reason why a lot of students struggle in math and struggle in algebra is because you have rushed the process of the learning. You have to go through, become very quick, become very solid with your steps, and then you can skip steps like I can here. So my final answer here works out to be 30x. I'm going to be using the OHAV technique for this one, just mixing it up, showing you that everything that I taught in the last tutorial video, which a link is in the description box below, all that I've taught here is in fact being applied. So here I owe 3 and I have 1. After paying the 1 that I have, I'm going to still owe 2. Now at this point with these 2 numbers, I now owe 2 and I owe another 1 on that 2. So now I end up owing here 3. And over here then I have 4. There's no sign in front of the 4, so it's positive 4. I have 4 and I owe 5. This makes me now owe 1. And if I owe 1 and I owe 7 more on that 1, then you'll find here that I end up owing, say here, 8. So my final result here is 30x raised to the minus 3 y to the minus 8. And that pretty much wraps up that particular question. So 2 examples where the powers are all positive, another example here where the powers are mixed with negatives and positives. But then what happens then if we are dividing then? Let's look at 2 examples like this one here. I think I might be here with you for maybe another 15 minutes. So we're just going to bring this class to maybe like an hour session. Again, if it is that you're watching the content, do not watch in full. If it is that your brain is incapable of managing so much information, you can watch, have a snack, have a drink, return, and soak more mathematical information in your brain so you can take your time and develop as a student. Ensure that you have your pens and pencils out and you're working with me as I write these examples. Pause the video, match your solution with mine. Here we go. Then what then if we have, say here, 12x? Since we used x and y, let's use some a's and b's then. So let's say we have 12a. Let's zoom up here for you. So 12a to the 6, b to the 3 divided by, say here, 2a to the 5, b to the 8. Again, say here, we can do straight division, divided by 3 a, say here, b. All right, so when we have this type of expression here, we don't usually get an exam question with straight division, but it's possible. It depends on your instructor and what objective you're trying to bring across. But most times we never have to divide more than 2 numbers at the same time. But nevertheless, let's apply here. We have 12 divided by, let's just keep the same consistency. See here we have 12 divided by, say here, 3. Again, say here, divided by 2. And then we have then, say here, a to the 6 divided by a to the 5, that's this a over here, divided by, say here, a. We already discussed that once there is no power, there is an understood power of 1. Now bear in mind that our final solution is going to merge the coefficients with the variables. So then we're going to be attaching here a multiplication sign to join our a's with our b's with our coefficient. All right, a lot of students ask, why are we dividing and then where did the multiplication come from? The multiplication sign here is as a result of we wanting to merge our answer to look something like this. Okay, we want our answer to be in one accordance. Okay, so that's why I have that multiplication sign there. All right, so then we're gonna have next here for us b, this b over here, b to the 3, multiplied then by, oops, not multiply, we're gonna have here divided by this b, which is b to the 8, divided by this b, which is b to the 1. Okay, now that everything is organized in order, again say here 12 divided by 3 is 4, and 4 divided by 2 is in fact going to be, say here, 2. Then we have a, the power here is 6. Because we are dividing, we're going to be subtracting the power of 5. We're going to be subtracting the power of 1. 6 take away 5, take away 1. That's going to be b. 3 take away, say here, 8. Take away here, say 1. Okay, then now finally we end up with 2a. 6 take away 5 is 1, and 1 take away 1 is 0. And finally here b, here 3 take away 8 is negative 5. All right, we understood why that is negative 5. Negative 5 take away 1 is negative 6. This is our final answer. Or for students who are a little bit above this level, you would have learned that a to the power of 0 is 1, and so if this turns to 1, then 1 multiplied by 2 is 2. So we can have an even more simplified answer of 2b raised to the minus 6. Oftentimes we teachers say if you raise a number to the 0, just for simplification purposes and understanding purposes, we say that a to the 0 makes the a disappear, but it really hasn't disappeared. It's really a to the 0 is 1. 1 times 2 is 2. 2 multiplied by b to the 6, b to the minus 6 is 2b to the minus 6. And that's basically what we have there. All right, so we don't usually get straight division. What you might see then is this. For example, then we end up with a question then like this, where we end up with 4, say here, x to the square, say here, let's use y, let's keep it consistent, x squared y 3. Then we end up with, say here, multiplied by 5 x to the minus 2. Let's mix it up, guys. Y to the negative 4. We're going to divide this then by, say here, 10 to the 10x y minus 7. All right, now we have a bunch of negatives and positive mixed up, and we have two different operations, and the two different operation brings out two different rule. So now we're gonna have to differentiate which power do I add to which power, and which power do I subtract from which power. And if you want to effectively work a question like this without any glitch, without any problems, then you're gonna find here simply that by taking out the coefficients, then like this, 4 multiplied by 5 divided by, say here, 10, then you'll find here that that's what we end up with. And then obviously then we're going to end up, say here, with the x here squared. We're going to be multiplying this by this particular x here, x to the minus 2. Then we're going to be dividing it then by this x over here, which is x without a power but an understood power of 1. Remember, our answer will be merged together by this period sign here, multiplication. So we have this y over here. We have this y over here. So we end up with y. Oops, you guys can't see that. I'm so sorry. Need a darker page for that one. Let's say here that we end up with, all right, let's use that color. Y to the 3, we're going to be multiplying it by this y over here, which is y raised to the minus 4, and then we're going to be dividing it by this y over here, which is y to the minus 7. So then what do we have then? It's 4 times 5 is 20, and 20 divided by 10 is in fact going to be 2. All right, now it doesn't mean that because I've written questions that's giving me solid numbers doesn't mean that you can't get questions, which I'm not going to be going through, but it doesn't mean that you're always going to get a solid coefficient for your answer. You could get a fraction for your answer, you could get a decimal for your answer. Again, it really depends on the practice paper and the source or the site. For exams though, we don't usually tend to bring out too much from the students. We keep it very simple, so we're going to end up with answers most of the time on practice papers from this level with solid coefficients for our answer. So this becomes 2 here, then this x here is x to the 2. Because I am multiplying here, I'm going to be adding this negative 2 here, but then over here I'm dividing it by this 1, so I'm going to be subtracting the 1 here. Hopefully you guys saw that. Okay, then we have y, then this is the 3 that I'm multiplying by this negative 4 here. I'm multiplying by this y to the negative 4, so I'm going to be adding the negative 4, and then of course here I'm going to be subtracting. Then remember that this subtraction sign here, let's just make sure that we indicate this subtraction sign that is here in red is because of this division here, but it's independent from the minus 7 that is right here. So that's this minus 7 here. And if I ever lost my student, I usually lose my students right at this point. They become very flustered, very confused, because they're trying to work the math in the head. If you do that, then I'm expecting that this video is not for you. But if you're watching this video, clearly this must be a topic that you're having issues with, so it is recommended that you do the problem as you see it here. All right, so then we end up with 2x here, 2. There's a clash of sign here, so this negative with this positive becomes a negative 2, and then this becomes a minus 1. All right, remember, you guys can actually work this in your mind, or if you decide to use the calculator, please type in the calculator exactly what you've seen. So we have y here 3, a clash of sign here, that's minus 4, and a clash of sign here, negative multiplied by negative, positive 7. So easily now our final answer here is in fact 2x here. 2 take away 2 is 0, 0 take away 1 is minus 1, and y 3 take away 4 is negative 1. Oops, not finished. 3 take away 4 is negative 1. Negative 1 plus 7. Mathematically, you guys should be at the level where you know that the answer is in fact 6. And please bear in mind that this answer could be rewritten as 2y to the 6 all over x. But you guys have to subscribe to the channel and be notified whenever I come up with more advanced math concepts like this. How to rewrite negative algebraic expressions to positive algebraic expressions. All right, so these are just the type of questions that you may end up seeing on the exam paper. Not just my exam paper, but you see these on exam papers in general. This is where the algebra is at the moment. Now, within, I say here, 1 hour of watching videos on my channel, you have just learned something about algebra that probably took you 2 to 3 years to learn. So I do hope that this particular video here was of some value to you. I don't see where I can give you another example. I may be able to squeeze in an example with a fraction. Let's do another one. Let's try to make it as complicated as possible, right? I could have ended the video keeping it very simple, but I feel like just in case your teacher tries to pull a rabbit out of the hat on you, you should be prepared, and this video should comprehensively cover everything. So let's have a look at a mixture with negative, positive, and of course, say here, fractions. So let's say here that we have let's say that we have 20x to the half, say here y to the negative 3 divided by here, say let's say 10x to the minus 2 y to the positive 4, and say here multiplied by 4x to the negative 3/4, say here y. Okay, let's do, say here negative 3/4 here, and let's do y to the positive 5. All right, and this is really pushing the boundaries. This is really where, as a student, you've become really solid and you're really searching for a challenge. If you're ever going to get a challenge at this particular level in math, it probably won't get any higher than this type of question using what you've learned so far in the first tutorial and this one. So let's round this video out under an hour and let's see exactly what we can learn here. Finally guys, let's wrap this up. Let's take out our coefficients. All right, if you get a question like this, just be patient, be calm, and remember that it's the same math as the very first one that we did in this tutorial. So we have 20, say here, divided by 10, again say here multiplied by 4. We're going to take out all the, say here, x's. So this is x to the power of a half, and I'm going to be dividing this then by this x here, which is x to the minus 2. I'm going to be multiplying this then by this x over here, which is x to the minus 3/4. Okay, all right, and then now remember that we're going to be merging our answers together with this multiplication sign here. So then what we have now is in fact y to the negative 3. Okay, let me just use a different color ink here guys, hold on. All right, so we have y to the power of minus 3, then say here divided by this y here, which is y to the negative 3/4. I hope you guys are not thinking that I'm purposely trying to make this math difficult, but I really need you guys to understand that this math can come in so many different forms. When you think that's the end, it's only the beginning. All right, so now that we have everything laid out here, let's do our calculation. We're gonna have, say here, 20 divided by 10 is in fact 2, and 2 times 4 is in fact, say here, 8. The base here is x, so we have a power of a half. Because we are dividing, we're going to be subtracting, and remember that this subtraction sign here is very much independent from the subtraction sign that you're seeing there on the negative 2. So let's make sure of that. Then we're going to have plus, then because we are multiplying, we're going to be adding negative 3/4 here. All right, then now we have y here, say minus 3. We are dividing here, so we're going to be, remember again, this subtraction sign is independent from the minus sign that is on any of the powers that may appear in the question. So then it's going to be minus 3/4. Okay, and that's going to be adding, because I'm multiplying here. Right, I didn't use the multiplication sign here. I have to use a period because I don't want you to get confused with the x and the multiplication sign. So that's plus the power of 5 here. All right, when you think the math is over, it's not, it's just beginning. So then we have 8x here, a half, okay, plus 2. Negative times negative is positive, you've seen that before, and positive with negative is negative, negative 3/4 here. Then we have y minus 3, negative times negative is a positive, 3/4 plus 5. So now we have a mixture of adding whole numbers with fractions. We can just pretty much turn everything into a fraction. So we can simply send here, say, put the 2 over 1. Oops, pardon me guys. I'm gonna put the 2 over 1 and put the 5 over 1, put the minus 3 over 1, and find the LCM. So what we have here is we know the answer is going to be 8x. So this is going to be, say here, a half. Okay, we're gonna just do it right here instead. We can find the LCM here, which is going to be, say here, 4. And so 2 into 4 goes 2 times. 1 into 4, 4 times. 4 into 4, 1 time. So 2 times 1 is in fact going to be, say here, 2. Plus 2 times 4 is 8. 3 times 1 is minus 3. So 2 plus 8 is 10. 10 take away 3 is 7. The y, we're going to be going ahead and find the LCM here. LCM here is in fact going to be, let's just give some more space. LCM here is 4. 1 into 4 times 4. 4 into 4 times by 1. 1 into 4 times by 4. So negative 3 times 4 is negative 12. 3 times 1 is 3. Plus 5 times 4 is 20. So when you mathematically work this out, whether on calculator or by hand, you should find out that the answer is 11 over 4. Negative 12 plus 3 is negative 9. Negative 9 plus 20 is positive 11. So our final result here is 8x to the 7, y to the 11 over 4. And so looking at this, it probably looks a bit complicated. But if you take your time, sort through the signs, sort through the addition of the numbers, then easily you'll find that what appears to be a very difficult question will work out to be quite a doable question. All right, so that brings us to the end of this particular tutorial. I do hope that I covered a lot of stuff. You can make these questions up, guys. Try to use numbers that can multiply and easily divide each other, and you can use any combination, fractions, negative and or positive, avoiding the decimals, please. And you're gonna find that you become a very more consistent and efficient math student. I do hope that this tutorial was off in its full package, and please share this out. Hit the like button before you go. Leave your comments down below if you have gotten some sort of clarity on a concept. All right, until then, I'll see you in another tutorial. I'll see you next weekend for more exciting math videos. Until then, take care. Bye bye.